Senior Application Engineer with Geomagic, and today we're back for another Inspection Insights episode. What we're going to do is, instead of consumer products like we've been doing the last few weeks, we're going to move on to an industrial product, and this time it's going to be a helix. Now, some of you may remember the reverse engineering lab that Greg did a couple of weeks ago, where he inspected this very same part. Didn't inspect, he reverse engineered this very same part, or reviewed a model that was created in Geomagic Design X. But today we're going to inspect it. It's much more difficult to model this kind of geometry than it is to inspect it. It's fairly simple and straightforward. With obviously reverse engineering, you've got to find the helix angle and do a bunch of sweeps or revolves to make all of those specific cuts to create this profile. Once it's created, though, we're really just comparing the CAD data or measured data to the blue reference data or scan data in this case. Now, here is a typical inspection workflow. I show it every single time that we do these kinds of Inspection Insights webinars. We start with CAD data and scan data, import the two, and then align them. Again, nothing crazy. I'm gonna spend a whole episode on Inspection Insights talking about alignments, but today we're just going to do our basic initial alignment and then a best fit alignment. Then we get into our inspection. That's where I'm going to spend most of the time today, creating some 3D comparisons, measurements, etc. And then we get a report. Once we've created this report or this template that is, all of the different inspection elements we're looking for, if we ever want to come back and inspect it, it's going to take 1/10 of the time to set up because we've already created the template. All we have to do is replace the measured data or the scan data, hit regenerate, and then we just repeat this inspection very, very quickly. For those of you new to this inspection series, we also have 3 different plans for Geomagic Control X. We have Essentials, which is our bare bones offering, pretty decent for anybody just starting out in inspections. They don't have high volume of inspection reports to do, and they don't necessarily need to scan directly into the software. A really good middle ground between Essentials and the professional version is Essentials Connect. Now, this has all of the tools that are involved in the Essentials. So, import, align, create an inspection report, and create an inspection template. But you also now get the ability to scan directly into Control X with our Direct Scanner plugins for handheld scanners, and also the portable metrology devices, so for arms and things like that. Now, if you need a little bit more from that, we can also look at Control X Professional. This has a few more tools, including tools for automated inspections, so setting up a template, having a server, and then just every time new scan data is dropped into that folder, it automatically runs an inspection and saves the report into a different folder. You can also have multiple result inspections, surface defects, import native CAD files, and some more advanced tools like the aerofoil analysis. Okay, so now we can move on to the main event and actually look at Control X. So for many of you, you should be pretty familiar with what Control X looks like, but if you aren't, it is based on a Parasolid CAD kernel where we have these toolbars at the top, very similar to CAD. On the left-hand side, we have our feature tree. Essentially, it's our results data. And at the bottom, we have an error list or a table view that we can see the results that we take. Okay, so we've got our CAD data. You can see here it is in silver. I can turn that off, and I can turn on my measured data. This is the scan data. Now, a little hack for you guys, if you want to know, if you come to Properties tab, if you want to change the color of this, I like the purple, but it's a little bit dark. So there are a few things you can do. You can either come in and change the material color, change it to blue, or if you wanted to, this is something that you may or may not know. If you're struggling with trying to look in an area and it's it's too dark, you could always come in and change the lighting of the scene. So you can see here, we can turn all of the lights off and it's very, very difficult to see, but we can leave some of them on. and I like to just leave all of them on, so then it's equally lit from pretty much every side. But you can decide for yourself. So once we've got our measured data and our scanned data, we do an alignment. Now I just did an initial alignment up here from the quick start menu, and then I did a best fit alignment. Now this best fit was just pretty standard. If there was some damage to the part, or I wanted to use, specific like areas to do this alignment, I could. But a best fit is just fine for now. Okay, turn off my measured data, and the first thing I always like to do is a 3D comparison. Now I can select pretty high resolution. Let's turn it up a little bit, see if we can get some of the logos showing up. And there we go. We've got our 3D comparison. Anywhere I want to add an annotation, I can come in and just click, and there we go. We've added, oops, one more. There we go. We've added our annotations. And I'm going to leave them like that. Grab this 3D compare, hit reassign viewpoint, and there we go. We've updated our screenshot as well. I'm just going to delete this other one that we don't need. Perfect. Okay, so we've done a 3D compare, and I can turn that back on again to see if there's any particular areas that we want to investigate. Bit of weirdness over here. Bit of weirdness over here. So maybe we want to do some cross sections in this area. Okay, turn off our comparison, and we can do a 2D compare. Now, if I want to, I have to select the base plane. So I can select this top plane here and then move it down to this area of deviation that we saw. Hit the next icon, and we get our 2D comparison. And again, increase that whisker multiplier, decrease the number. We can see we've got some problem areas here, so I can probe those. And if I wanted to, I could also decrease my tolerance, or increase the or decrease the range, etc. Hit the check mark. There we go. We've added a 2D comparison. Now, if we were actually inspecting something like this, what we'd probably want to do is come to our Dimensions tab and start adding some surface profile callouts. So we can grab this cylinder, hit the check mark. You can see there it measures it, and we can even see in our table view value is 0.127. Now we can come in and add some more surface profiles. We can grab this. I don't know if I want to use that face. I might want to use this face. Okay, there we go. Come in, and really anywhere we click on the CAD face is going to be giving us a surface profile. So we could go through and do a surface profile of this whole part. Typically, I'm going to get more information myself from just reviewing the 3D compare, and then going from there. But if we wanted to, we could also do either a 2D compare, we just did one, or we can do dimensions, and instead of doing our surface profiles, we could also do like a linear dimension, a radial dimension, grab the cylinder, assign a tolerance, hit the check mark, and there we go. We've added more dimensions. We can even add a linear dimension, do like a end-to-end measurement. So I grab this plane. If you wanted to grab all 4 of these, you just hold the control key. You can see there it's going to say, do you want to make it a composite selection? And we do. So we're going to select this, and then we come to the other side and grab this face. There we go. We've done an overall dimension. Come in and add our tolerance. Here's another quick tip. Hopefully most of you know this already, but if you ever have asymmetrical tolerances, so say it's plus 0 minus 0.1, we can write that by doing plus 0, and then this little squiggly line. I don't know the technical term. Please mention it in the comments if you do. We can say minus 0.1, check mark, and there we go. We've now got plus 0, minus 0.1 as our tolerance. So we don't have to just stick to equal tolerances. Okay, there we go. We've done our first group. And of course, I'm going to make sure that the screenshot looks nice and pretty for my report. Perfect. Now, what I want to do, I can turn that group off. And I can actually do a 2D GD&T. So I can do a 2D cross-section. It's going to ask me, so we're going to need to add a section. And it's going to say, we could always do by rotation, and we can say, hey, this cylinder is our rotation axis, and the base plane is going to be in the Z direction. Let's see. We can use X, that's fine. And you can see there we've got our cross section, and because we've set it up for rotation, we can just drag this green arrow and rotate it however we'd like around the part. So I'm going to call that good. Hit the check mark. And now, instead of a 2D comparison or 2D compare that we've seen in previous videos, we have a 2D cross section. This is very similar to a mesh sketch where you've got the dotted line, that is the measured data, that is the scan, and we've got the dark black line, which is the reference data or the CAD model. So anywhere that you see this dotted line, the measured data is, obviously more inset than the CAD model. But most of it's looking pretty good. We just know that there's some deviations over on this side, and there should be some deviations, down here as well. But if we wanted to measure this cross-section, we can treat it like any other 2D drawing. So we can say, hey, I would like to measure, the distance from here to here, and this is essentially a radial dimension. It's just taken on a cross-section. Come in and add our asymmetrical tolerance. Why not? And then we can start measuring, if we wanted to measure the angle, well, we could say, hey, from here to here, give it a tolerance, it's plus or minus 1 degree, that seems fine. So we can start measuring all sorts of different things. We don't have to just do like surface profiles for the whole thing. If we wanted to do, another dimension, so maybe we wanted to measure, come in radial dimension, grab this radius here, assign a tolerance, hit the check mark, and we can go around and dimension, this whole cross section if we'd like. Once we're happy, we can press this 2D button and we exit the command. Nope, we just have to hit home. Selecting this is not going to leave the tool, it's just going to decide if it's going to ask you for a section or it's just going to give you, the ability to take dimensions. So we've added our cross section there. We've got our 2D comparisons as well. I think that should be it for this inspection. Yeah, like I said, we can do surface profiles. If we wanted to do a bit of run out, we could. Obviously, flatness isn't particularly useful, and then most of these also require datums, which we haven't set up. If we wanted to, we could always come in, add another group, add a datum. Maybe we wanted to, make this cylinder as my datum A, and then I want to do a concentricity call. Let's do some more datums. Let's do this plane here as datum B. There we go. Okay, so we've got datum A and B, and then we can start doing, if we wanted to do a position tolerance for, this error in the bottom. You can say, hey, let's do this cone, and it needs to be between A and B, and hit the check mark, and there we go. We've added position tolerance, and we can even add concentricity for some of these holes. So we can say, hey, the cylinder needs to be concentric to that cylinder B. We can give it a pretty tight tolerance because it seems like it should be concentric. It's not datum B, it's datum A. There we go. That's why it's saying invalid. Check mark. Let's see what dimension we're actually getting. Concentricity, measured value 0.134. Okay, tolerance is 0.1. So if we change this, if we change that tolerance to 0.15, for example, 0.015, and hit the check mark, yeah, you can see that it turns yellow because it is essentially a warning. It's not out of tolerance, but it is trending pretty close to there. So it's like one of those things to just be, hey, this passes, but just watch out for it. Obviously, green being like this is well within the tolerance band. You don't need to worry about it. But yeah, so that is how we're going to dimension stuff. Like I said at the beginning, if we've created this and we just want to inspect another one, well, we can just come in and come to our home tab and replace measured data. We'd then import another scan, and all we'd have to do is hit a refresh icon, and then we've inspected another part. As with all of these inspection insights, at the end we come to generate report. Give it a second to load. We can decide what we want included. Now, I don't want the initial alignment. I don't really need that vector included, but the 2D compare, 3D compare, and then our cross-section and groups definitely need to be included. So I hit generate, and this is the report that I'm going to be saving out. So you can see here we've got our reference data, scan data, the alignment. This is the best fit alignment, not the initial alignment. We removed that. 3D compare, 2D compare, and then a cross-section, that 2D cross-section. So you can see how it differs from the looks of a 2D comparison. 2D comparison, you get a colorful line, but you can't use this to take measurements from. You could just take comparison points. 2D cross-section or 2D measurements, it gives you that 2D cross-section, but it's not colorful. It doesn't show you the deviation from the scan to the CAD. It just gives you black and dashed lines. And then with that, you can then take dimensions like I showed you earlier. So that's the difference between 2D compare and 2D cross-section and 2D result. Obviously, we've got our dimensions here, and then we've got another group, all of the table results here, and then a group 2, which is all of those datums and the concentricity callouts that we created. And there we go. We're happy. Save it as a PDF, PowerPoint, Excel, whatever you'd like. Add a header, footer, etc. Add your own image if you'd like. Whatever you want to do, and then you've got a template that's ready to go. So yeah, that is everything for this time. If you have any questions, please don't hesitate to reach out to either myself or somebody else on our team. We'd be happy to sit and have a conversation with you. And yeah, hopefully you learn some stuff. See you on the next one. Bye.